Hi, so today we're doing Chapter 9, Lesson 7. So you'll turn to page 776 in your book. We're doing independent and dependent events today. And I think it's going to be easiest if we just talk about the two vocabulary terms right at the very beginning before we get started. And really, this is stuff that we've been doing with the fundamental counting principle and with permutations. It's just now they're kind of putting a different name to it. Okay, so hopefully you see the connections from the things we've already been doing. So independent events. Independent events are when one event does not affect the outcome of the following events, the second event, third event, whatever comes afterwards. So an example of that is spinning a spinner and then flipping a coin. Now, the reason these are independent events is because whatever I spin on the spinner has no effect on what I'm going to get, heads or tails, on the coin. Okay? It doesn't mean that if I would have gotten blue that I would have gotten tails instead. They do not affect each other at all. That means they are independent from each other. Okay? Dependent events are when one outcome of one event affects the outcomes of the following events. So an example of that would be like picking a marble out. Notice it's really important that I said do not replace it. So I pick a marble out, I don't replace it, and then I choose another marble. Now, what I pick on the first time makes it a different amount for the second time. So my second draw depends on my first draw. So that's where the dependent comes in. So like imagine that I only have 2 marbles. So my first pick was blue. So obviously my second pick depends on whichever one I chose first, because now there's only a red left. Where if I would have chose red first, now my second one depends on that I chose red first. Okay? But if I would draw a marble out and put it back and then draw, then it really didn't matter which one happened first because we still have the same amount of options. Okay? So dependent is when it's affecting the second draw. I pull the green out. Now I only have 1 green compared to all of the others, so I have less green to choose from. So that's the difference between independent and dependent. We're going to practice this a second. It's going to pause the video and ask you what you think after each one, and then I'm going to tell you what it should be. So rolling a dice and then rolling it again. So do you think that's independent or dependent? Hopefully you put that, and I'll keep this out, so hopefully you can kind of use that to help you. So rolling a dice and rolling it again, hopefully you put independent, because I rolled a 4, but that 4 has no effect on what I roll next. Luckily I got a 4, but I could get anything the next time. They do not affect each other. It is independent. Picking a piece of candy and then picking another. So what do you think about that one? Okay, so I have a few pieces of candy again. So I pick a piece of candy, and when I go to pick another one, notice now there's less options. I don't have that sucker option anymore. So that's a dependent event. Once you take one of the events out, now there's less to choose from. That's like that permutation we were talking about. So the second one is dependent. The third one, spinning a spinner and drawing a marble. What do you think about that one? Hopefully you said those were independent. Okay? Whatever I spin here does not affect which marble I randomly draw out of the bag. And the last one, being selected for Student of the Week. Now this one's kind of tricky. That one, you have to think about it as once you've been picked for Student of the Week, they're not going to pick you again that year. So your name is taken out of the drawing for the next week almost. So that's dependent because let's say, I don't know, Mia got Student of the Week, and once Mia gets Student of the Week, Mia can't get it again, so then there's everybody else is left as the other option. So dependent. Okay. So looking in the workbook, you'll notice hopefully the first couple examples look pretty easy because we've already been doing independent events a lot. Okay, so the first one says one letter tile is selected and the spinner is spun. What is the probability that both will be a vowel? Okay, so probability of, let's do the tiles first. So the probability that on the tile we get a vowel, well, there's 1, 2 vowels out of 4 total. And for the spinner, there's 1 vowel out of 3. So we say our 2/4 times 1/3, and that gives me 2/12, which simplifies to 1/6. Okay, and the book shows you both methods, one where we made our sample space and looked and found that here I have, let's see, 2 vowels, here I have 2 vowels out of a total of 12 outcomes. So that's our 1/6. And then down here, method 2 is the one that I just showed you. Find the probability of each, multiply them together. Example 2. In example 2, it says the spinner and the number cubes shown are used in a game. What is the probability of a player not, make sure you're paying attention to that word, not spinning blue and then rolling a 3 or a 4? Well, again, break it up. First it says not blue. Well, the probability of not spinning blue, that means I could get purple, red, green, or yellow. So that's 4 out of 5. And then the probability of getting 3 or 4. Well, that's 2 of the numbers. Here's my 3, here's my 4. 2 of the numbers out of 6. So I take those 4/5 times 2, 6, and multiply them together. And 2 times 4 is 8, and 5 times 6 is 30. Now, for right now, if you're using a calculator, you know how to simplify it, and you end up simplifying and getting 4/15, great. Since we're not used to not having these calculators for us to help us simplify, if you leave it as this, I won't count it wrong right now as you are doing your assignments. I'm not quite sure how Alex works with that. I will update you once I know. Okay. Let's go ahead and try our got it problem. Got it problem says a game requires players to roll 2 number cubes to move the game pieces. The faces of the number cubes are labeled 1 through 6, so it's just a normal dice. What is the probability of first rolling a 2 or a 4 and then rolling a 5? So go ahead and try that one on your own. Well, for the first part, rolling a 2 or a 4, that's 2 options out of a total of 6. And then when you look at it, then rolling a 5 on the second number, well, that's 1 out of 6. So when we multiply those together, 2 times 1 is 2, and 6 times 6 is 36. Again, I know I can simplify that, so you can go to a calculator for help, and actually if you use the calculator that I link in Google Classroom, under the classwork tab, you will find an online calculator that will simplify for you, so you could do it that way. So that would be your answer. Now, if you didn't notice, all of the ones that we've done so far, these have been independent events. Picking a tile, spinning a spinner. Those don't affect each other at all. No matter what I pick here has no effect on the spinner. Same thing, spinner and the dice here. Same thing, rolling the dice twice. Has no effect on the second roll. Okay? Here's some examples of dependent events. Remember, dependent means, let's grab this, when one outcome affects the second or following outcomes, okay? And they gave the example, just like I said, that you pick a marble out, don't replace it, and pick another one. So for example 3 says, there are 4 oranges, 7 bananas, and 5 apples in a fruit basket. Ignacio selects a piece of fruit at random, and then Terrence selects a piece of fruit at random. So Ignacio gets to choose first, then Terrence. Find the probability that 2 apples are chosen. So I have this on a separate page to kind of explain it to you. So we want the probability of getting an apple and then getting another apple. Okay, so we do each event individually. What's the probability of getting an apple? Well, they told us there are 5 apples, and I went ahead and added them up. There's 4 oranges, 7 bananas, 5 apples. And when you add that up, that's 16 total pieces of fruit. So I know that when they reach in and randomly try to pull out a piece of fruit, there's 16 total options, and of those 5 are apples. Okay? From there, they're saying that the first person chose an apple, which means that apple now went down to 4 because he chose one of those 5 apples. Well, if that goes down to 4, that means this goes down to 15. So now when we go to choose an apple for the second person only has 15 total pieces of fruit to choose from, and out of those 15 pieces, they only have 4 apples as their options. Okay, so some people get confused and they put 1 on the top because they think, well, the first person picks 1 apple and the second person picks 1 apple. It's not how many they're choosing, it's how many of those favorable outcomes or what they want to happen, how many of those are there. So there was 5 apples to begin with, but once the first person picks it, now there's only 4 apples to choose from. And we multiply straight across. So 5 times 4 is 20, and my 16 times 15 is 240. And again, you can simplify that. If you don't simplify it, don't worry about it. This is what I'm worried about right now, that you understand how to get the correct number. Okay? So we need to try our got it problems. So the got it problems, it says refer to the situation above. And when you go to do this 2 bananas, we're starting over. So we still have that 4 oranges, 7 bananas, 5 apples. It's not that the 2 apples already went away. Okay? So when you start each got it problem, you're starting over again. So go ahead and try got it B. So with got it B, we have 2 bananas. That means get 1 banana, then get a second banana. So the first person, the probability that they get a banana, well, that's 7 out of 16. Once somebody chooses a banana, now there's only 6 left and 15 pieces of fruit left. That means that second person that wants a banana, they have 6 options for bananas out of a total of 15. And we would multiply those together. And that calculator that I told you about that I have linked on Google Classroom, you can multiply fractions within that calculator and it will simplify for you like this one just did. Okay? Got it C, go ahead and try that one. Now got it C is just slightly different because before it was always the same piece of fruit that we were going for. Okay, so first probability of getting an orange, well that's 4 out of 16 total pieces of fruit. Then we've picked an orange, so that's 3, that means we have 15 pieces left. Now, the way this is different is the next one's apple. Well, there's still 5 apples left. We don't go with 3 because they don't want an orange for the second one. We want apple. Well, there's 5 apples left because no one's picked one of those yet, out of a total of 15. Okay? And if you don't have the calculator and it's simplifying for you, just so you know, 4 times 5, you get your 20 on the top, and your 16 times 15, we get the 240 on the bottom. If you are using a calculator that simplifies for you, when you multiply, you end up with 1/12. Okay? These are dependent events, because once you pick one item, it's no longer there for the next person to pick. So the options for the second person depends on what the first person did. Okay? In your exit slip for today's, we are going to be working on a few of these problems. So I want to talk about them just a little bit with you. Okay? So you're going to have to do number 3 in your exit slip, so we're going to look at number 4 together. It says, a number cube is rolled and a marble is selected at random from the bag at the right. Find the probability. So first part, probability of odd. Well, that's with a number cube, that's with a dice. So our dice, we have 3 odd numbers out of 6. And then we have the probability of not green. Well, if you look at this, first of all, there are 1, 2, 3, 4, 5, 6, 7, 8 marbles. And if I want not green, there are 1, 2, 3, 4, 5, 6 that are not green, because 2 of them are green. So we would take those 2 and we would multiply them together. So we have our 3 times 6, that's 18. 6 times 8, that's 48. And again, if you want to leave it that way because you're struggling with simplifying, that's okay. But if you have time to simplify it, you know what you're doing with that, go ahead and simplify to your 3/8. Okay? That one, think about whether that was dependent or independent. Go ahead and answer that. Hopefully you said that one was independent, because whatever happens with the dice has no effect on what marble we choose. Now let's look down here. You are going to have to do this question and this question. Notice I changed the numbers to make them a little bit smaller, so hopefully it's a little bit easier to work with. Okay, so it says Mrs. A's class has 2 students with blue eyes, 4 with brown eyes, 3 with hazel eyes, and 1 with green eyes. 2 students are selected at random. Find the probability. Remember, when you think about this, I pick on one student and a different student. Okay? I can't pick on, let's see, I can't pick on Kimberly and then pick on Kimberly again. Okay? It's 2 different students that we're talking about. Alright? So, think about really quick if this is independent or dependent. Hopefully you said dependent, because like I said, if I pick Kimberly, I can't pick her again. I'm picking 2 different students. Okay? So when we go ahead and look at number 10, brown then brown. And again, I changed that one. Okay, I changed that one. That other word was something different. Okay. So if we have 2 with blue, 4 with brown, 3 with hazel, and 1 with green. Well, when we look at that, 2 plus 4 plus 3 plus 1, I have 10 total. So the first probability of brown would be 4 out of 10. Once I pick one of those students, though, now it goes down to 3 out of 9. So I would multiply those 2 together. Hopefully you have a good understanding of what dependent and independent mean, how to tell the difference between the 2, and as always, let me know if you have any questions. I would be more than happy to help.